Hey there folks, welcome to a world where warfare isn't just about what you see on the surface, but what's hidden deep below. Today, we're peeling back the layers, literally and figuratively, to explore one of the most fascinating and formidable weapons in the modern military arsenal. I'm Mike Rowe and we're about to dive deep, underground in fact, into the world of bunker busters. These aren't your average bombs. They're massive, specialized munitions designed to take out the most heavily fortified and deeply buried targets on the planet. Think of them as the sledgehammers of the sky, built to smash through the toughest defenses that modern engineering can muster. Imagine this: military command centers buried hundreds of feet below the earth, nuclear facilities shielded by layers of reinforced concrete, and weapons caches hidden in labyrinthine underground complexes. These are the kinds of targets that keep military planners up at night. Conventional bombs and missiles just bounce off or barely scratch the surface. That's where bunker busters come in. They're the answer to a problem that's literally buried deep. Over the years, engineers have developed a whole spectrum of bunker buster bombs, each tailored for specific missions. Some are designed for shallow targets, others for deep penetration. There are smaller, more agile versions for tactical strikes, and then there are the giants, massive bombs built to go where nothing else can. Each type has its own unique strengths, from the way it's guided to the materials it's made from, and the depth it can reach. But today, we're zeroing in on the king of them all, the undisputed heavyweight champion of bunker busters, the GBU-57 Massive Ordnance Penetrator, or MOP for short. This bomb is a true marvel of modern engineering, tipping the scales at over 30,000 pounds, and stretching more than 20 feet long. It's the largest non-nuclear bomb in the US arsenal, and it's designed for one purpose: to obliterate the most secure underground targets on Earth. This isn't your grandpappy's bomb, folks. Back in World War II, bunker busters were crude, heavy, and often imprecise. Today's MOP is a different beast entirely. It's the product of decades of research, technological innovation, and battlefield experience. The leap from those early bombs to the GBU-57 is like going from a sledgehammer to a laser-guided jackhammer. The GBU-57 is a precision-guided behemoth, equipped with advanced navigation systems that allow it to strike with pinpoint accuracy. When it's released from a high-flying bomber, it accelerates toward its target, using its massive weight and reinforced steel casing to punch through layers of earth, rock, and concrete. It can penetrate up to 200 feet of earth, or 60 feet of reinforced concrete before detonating its powerful warhead deep inside the target. We're talking about serious firepower here, enough to shake the ground and obliterate anything in its path. The shockwave from a MOP detonation can collapse tunnels, destroy bunkers, and render underground facilities completely unusable. It's a weapon designed to send a clear message: nowhere is safe if you're on the wrong side of its crosshairs. So, buckle up as we take a closer look at this engineering marvel. We'll explore how it's built, how it's deployed, and why it's become the ultimate weapon for taking down the world's toughest, most deeply buried targets. Get ready to get dirty, because we're going underground with the GBU-57 Massive Ordnance Penetrator. Alright, let's talk specs. The GBU-57 MOP is a sight to behold. This thing is massive, weighing in at a whopping 30,000 pounds. That's heavier than a fully loaded school bus. And it's not just big, it's long too, stretching over 20 feet in length. But the MOP isn't just about size, it's built for one purpose: penetrating deep underground and neutralizing heavily fortified targets. Think underground bunkers, command centers, and weapons facilities buried deep beneath layers of rock and concrete. This thing is designed to go where no bomb has gone before, delivering a devastating blow to even the most hardened targets. It's a weapon of last resort, reserved for the most critical and challenging missions. Now you might be thinking, Mike, a bomb's a bomb, right? If it goes boom, it gets the job done. But let's pause for a second and really dig into that idea. In the world of military munitions, not all bombs are created equal. Each one is designed with a specific purpose in mind, and the differences can be dramatic. Sometimes even the difference between mission success and failure. Think of it like a toolbox. Sure, you could try to use a sledgehammer for every job, but sometimes you need a scalpel, and other times you need a jackhammer. The same logic applies to bunker busters. The military has a whole arsenal of specialized bombs, each tailored for a particular kind of target, depth, or fortification. Choosing the right one is a science in itself. The MOP, or Massive Ordnance Penetrator, is the heavyweight champion of the bunker-busting world. It's the biggest, the heaviest, and the most powerful penetrator in the US arsenal. But it's not the only contender. There are other bombs, each with their own strengths and weaknesses, designed for different scenarios and aircraft. Take the GBU-58, for example. This bomb was developed in a matter of weeks during the Gulf War, specifically to take out deeply buried bunkers. At 5,000 pounds, it's no slouch, and it's been a reliable workhorse for decades. But when you put it next to the MOP, it's clear who's the heavyweight. The GBU-28 is more agile, can be carried by a wider range of aircraft, and is perfect for medium-depth targets. Then there's the Blue 109. This is the Swiss Army knife of bunker busters. Smaller, lighter, and incredibly versatile. Weighing in at about 2,000 pounds, it can be carried by everything from fighter jets to bombers. The Blue 109 is designed to punch through reinforced concrete and steel, making it ideal for hardened aircraft shelters, command posts, and ammo depots. Its versatility means it's used by air forces around the world. But when it comes to sheer, raw, penetrating power, nothing comes close to the MOP. This behemoth can burrow through over 200 feet of reinforced concrete. Imagine a bomb so powerful it could punch through the equivalent of a 20-story building made entirely of concrete and still keep going. That's the kind of force needed to reach the most heavily fortified underground bunkers, targets that would laugh off lesser munitions. To put it in perspective, the GBU-28, as impressive as it is, maxes out at around 100 feet of penetration. That's still a massive achievement, but only half of what the MOP can do. The Blue 109, while versatile, is designed for shallower targets, capable of breaking through up to 6 feet of hardened concrete. So, when the mission calls for the deepest, most impenetrable targets, the MOP is the only tool for the job. It's not just a bigger bomb, it's a game changer in modern warfare. So, we know the MOP is big and powerful, but what exactly makes this massive weapon so effective at hitting its mark? Let's take a closer look at the technology and engineering that goes into making the GBU-57 Massive Ordnance Penetrator, or MOP, one of the most formidable bunker-busting bombs in the world. It's not just about size or brute force, there's a lot of science and precision packed into this 30,000-pound behemoth. Inside that thick, hardened steel casing lies a sophisticated blend of high explosives, electronics, and advanced guidance systems. The bomb's design is all about maximizing its ability to penetrate deep into reinforced underground bunkers or tunnels before unleashing its destructive power. Engineers have carefully balanced the weight, shape, and internal structure to ensure the MOP can survive the intense impact forces as it slams through layers of earth, concrete, and steel. At the heart of the MOP is a delayed action fuse, a critical component that sets this bomb apart from conventional explosives. This fuse is programmed to wait until the bomb has burrowed deep underground, sometimes through dozens of meters of rock or reinforced concrete, before triggering the detonation of its massive 300-pound high-explosive filler. This delay is precisely calculated to ensure the explosion happens at the optimal depth, maximizing the destructive effect on deeply buried targets while minimizing the risk of premature detonation. By detonating deep below the surface, the MOP can destroy fortified bunkers, command centers, or weapon storage sites that would be nearly impossible to reach with other munitions. This method also helps to minimize collateral damage above ground, reducing the risk to nearby structures and civilians. The result is a weapon that's both incredibly powerful and surprisingly precise in its effects. But getting a 30,000-pound bomb to hit a precise target, especially one that's hidden deep underground, takes more than just raw power. It takes brains too. The MOP relies on a suite of advanced guidance technologies to ensure it stays on course from the moment it's released until the moment it strikes its target. That's where the MOP's state-of-the-art guidance system comes into play. This system constantly monitors the bomb's position, speed, and trajectory, making real-time adjustments to keep it locked onto its target, even as it travels at high speeds and faces challenging conditions. The MOP uses a combination of GPS satellite navigation and an inertial navigation system, which means it can maintain pinpoint accuracy even if GPS signals are jammed or disrupted by enemy defenses. This dual approach ensures the bomb can find its way to the target, no matter what obstacles it encounters. In the end, it's this blend of brute force, smart engineering, and cutting-edge technology that allows the MOP to hit its mark with devastating precision. Now let's talk deployment. The MOP is a heavy hitter and it takes a special kind of aircraft to deliver it. We're talking about the B-2 Spirit, a stealth bomber designed to penetrate enemy airspace undetected. Once the B-2 is in position, the MOP is released from the bomb bay, guided by its internal navigation system. As it plummets towards the target, the MOP's GPS receiver locks on, making minute adjustments to ensure pinpoint accuracy. Upon impact, the MOP's hardened steel casing punches through layers of earth and concrete, burying itself deep underground before the delayed action fuse triggers the massive explosive payload. The result is a devastating shockwave that can cripple even the most fortified underground facilities.